Hello, mathematicians. Yesterday we focused on finding limits from graphs, and today we're going to focus on finding limits numerically. When we say numerically, we mean by using a table of values. Let's take a look at this function here. We have g of t equals t to the 3 minus 1 divided by t minus 1 when t does not equal 1. So the reason we have to say when t does not equal 1 is because if we plug in 1 in the denominator, t minus 1, 1 minus 1 is 0. So anything when we divide by 0 is undefined. So that's why we have a hole here at 1. Now, if we want to find the limit as t approaches 1 of this function, graphically, we would look on either side. What are we approaching from the left? We're approaching 3. And if we're going from the right side, we're also approaching 3. So we're approaching 3 from both sides. So we say the limit as t approaches 1 is 3. Now we can also do that numerically. To do that, we can put it in our calculator. So I've put our function already in the calculator. Just as a note, you can press alpha y equals to get the fraction in there. So we can press trace and put in a whole bunch of different values. As t approaches 1, we want to find values that are a little bit to the left of 1 and a little bit to the right of 1, but very close. So a number close to 1 but less than 1 is 0.9. And even closer than that is 0.99. And even closer than that is 0.999. We could keep adding 0.999 until we got close and closer to 1. Now on the other side, approaching from the right, bigger than 1, we can add 0.001 to our value here. So 1 plus 001 is 1.001. And a little closer, a little bit farther, but still close, 1.01 and 1.1. So we can plug these values, we press trace, and we can put 0.9 in the calculator. And we get 2.71. If we put in 0.99, we get 2.9701. And put in 0.999, we get 2.997001. In general, for AP Calculus, I suggest using 5 decimal points. You need a minimum of 3, but you might get off for a rounding error if you only use 3, so use 5. And if we put in 1, we'll see that there is no y value here because it's undefined. If we continue, 1.001, we get 3.03. There's another 0 there. 1.01, we get 3.0301. And 1.1, 3.31. So as we get closer and closer to 1, from this side, looks like 2.7, 2.9, 2.99. We're getting very close to the number 3. If we're coming from this side, we're also getting closer and closer to 3. So we can see our limit is 3. Let's look at another example. This one is called a piecewise function because there are 2 pieces to the function. This says when the limit of as x approaches 2 of f of x, that's what we want to find. If f of x is equal to 1 if x does not equal 2, and 0 if x equals 2. So let's start by doing this numerically. We're looking when x is 2, so we're going to put in 2 there. And we're going to go a tiny bit bigger than 2. And a little bit bigger than that. And a little bit bigger than that. And then on the other side, we'll go a little bit smaller. So we're going to subtract 0.001. So 2 minus 0.001 is 1.999. And then we have 1.99 and 1.9. Now, if we are plugging these numbers into our function, if we have 1.9, are we in x equals 2 or x equals not equals 2? X not equal 2. So our value of a function is 1. Here again, x does not equal 2, so our value is 1. And again, at 2, our value is 0. So we're going to put 0 here. And again, 2.001 is close to 2, but it is not 2, so our value is 1. So if we're coming from the left side, we're going along here, what do we think the value is? Well, it's been 1 the whole time. And if we're coming from this way, we also see 1. Remember, the limit does not care what the actual point of the function is. So we're not going to use this when we're looking at our function. So the limit as we approach from the left is 1 and from the right is 1, so our limit is 1. This graph would kind of look like a straight line, except at 2 there's a hole and a point down there. The next case is absolute value. Absolute value is typically best done either graphically or numerically. Anytime you see absolute value, think of the graph or think of these tables. So here we're taking the limit as x approaches -2. So I'm going to put my -2 in our table. And we want a number a little bit bigger. Now remember with your negative numbers, so -1.999 is bigger than -2. 1.99. And then smaller than -2 would be -2.001. 2.1. So now let's take a closer look at this function here. We have absolute value of x plus 2 and x plus 2 on the denominator. So if we did not have the absolute value, this would cancel out and it would be 1. The only difference the absolute value makes here is the sign. So we have to be very careful about our sign. If we're plugging in something a little less than -2, in our denominator, -2.1 plus 2 would give us a negative number. It would give us -0.1. And if we plug in -2.1 plus 2, that's -0.1, but the absolute value sign makes it a positive. Notice we will always have the same number on the top and bottom, just the sign will change. So this will be -1. And you'll find the same is true with these. Try it out yourself. If we plug in -2, that would give us a 0 in the denominator. So that is undefined. If we plug in -1.999, we're going to have a number that's positive on the bottom and positive on the top because absolute value is always positive. And again, it will be the same number, so this will be +1. So this function will look like a negative straight line in the -1, and then it will go to +1 at -2. So if we're approaching from the left side, the value looks like it's -1. If we're approaching from the right side, it looks like it's +1. That means the limit does not exist because the limit from the left and the right are different. Let's look at the next case. A lot of students tend to get afraid when they see trig functions. Don't be afraid. They're your friends. So let's find sine. Let's put this one in our calculator. Y equals sine alpha y equals, enter for our fraction, 1 divide x. Okay, so let's press trace. What values are we going to look at on here? Well, x is approaching 0. So we're going to put 0 in the middle. A number slightly bigger than 0 is 0.001. 0.01 and 0.1. A number slightly smaller than 0, well, that number smaller than 0 have to be negative. 0.001, negative 0.01, negative 0.1. So if we look at these numbers, let's in our graph, negative 0.1 is positive 0.54402. Okay, negative 0.01 is giving us positive 0.50636. Negative 0.001 is now a negative number, 0.82687. 0 will be undefined. 0.001 is 0.82687. 0.01 is now a negative 0.50636. And here we'll get positive 0.54402. Now let's try and figure, what is it approaching? Well, here we're at positive number, here we're at negative number, here we're at a positive number, negative number, positive number. It's switching back and forth. We don't know what it's approaching. And if we zoom in this graph on our calculator, you'll notice this graph gets very jumpy. It goes up and down and up and down. We call this oscillating behavior. Sine typically looks like a wave, and that's oscillating as well. But here, as we zoom in even more, we'll see, let's go that right to the middle. It just keeps getting crazier and crazier. It just keeps going up and down and up and down. And no matter how close we get, we'll see even more oscillations. So this one, the limit, does not exist because it keeps oscillating. Let's look at our last example here. Y equals 1 divided by x squared. And let's zoom out again. Zoom 6. So we're looking as x approaches 0, just like we did in the previous one. So I'm going to copy those numbers in. And if we plug in our numbers now, negative, trace, negative 0.1, we're going to get 100. And trust me on this, or plug it in yourself, 10,000. This one was 1 million. Undefined, 1 million again, 10,000, 100. So as we're getting closer and closer to 0, we see the graph is going up and up and up. It gets to 1 million even. So this is actually approaching a positive infinity. Positive infinity. It's going up and up forever. We reached 1 million, but it will keep going up. And on this side, we're also approaching positive infinity. There are two different ways that textbooks would write that. Some people would say the limit is positive infinity. Other textbooks will say infinity is not a real number, so they would say the limit does not exist. In class, I would want you to write infinity because it's a little bit more descriptive, although some people would accept does not exist. So there are 3 reasons that a function would not exist. The first one, the value that is approaching from the left is different than the value that it's approaching from the right. The second example, the function is oscillating. It doesn't settle on a point. It goes back and forth between 2 different values. The third one is when it reaches unbounded behavior, or it approaches infinity or positive or negative infinity. So there you have it. You can evaluate limits using tables. One quick note, on the AP Calculus exam, some questions will have calculators and some will not. So be sure when you're practicing to check if the question allows calculators or not. Have a great evening.